So now in this section, we have two big topics. One will be about kind of tips and tricks and best practices for Docker files. So we're going to go beyond what we saw Tuesday, beyond like a copy and run and CMD. And another part is everything about optimizing image size. And the one big technique will be multi-stage builds. All right, so let's start with tips, tricks, and useful techniques. So one thing that we can do is reduce the number of layers, and very often the easiest way to do that is to combine commands like this. So this is an example where you're like, hey, I'm installing 3 packages and I'm using 3 apt-get install commands. Instead, I could just have like one apt-get install command installing these 3 packages. Which one is best? Well, honestly, it kind of depends. That doesn't make a huge difference. And reducing the number of layers, is that even an important thing? Not necessarily. There is a limit on the number of layers, a little bit above 100, if I remember well. And this is linked to historical limitations in the very first versions of Docker. It was using a system called AUFS to kind of assemble the images from all the layers, and AUFS was limited to 128 layers, I think. So if you remove a few layers used internally by Docker, you end up with 100 something max layers in an image. That we don't really have that technical limitation anymore because now Docker is using other systems, but I think we still have that kind of artificial limitation somewhere, like no more than 100 and something layers. In practice, will you ever hit 100 layers and so? Typically, no. I know only 2 real-world scenarios where you can have that number of layers, and both are very specific, almost kind of extreme, I would say. First example I've seen, that was years and years ago, it was on a system where folks were automatically doing a Docker commit, Docker run with the new image. So imagine you have this system that's running, and it's a kind of live system and you're working on it. And sometimes you have the option to kind of save. And when you hit that button, it Docker commit and Docker run the resulting image. So each time you hit that button, you end up adding a layer. And so if you do that long enough, well, you hit that layer limit. Now, that was a kind of, as I said, very specific, very special example. I don't really expect that you would have that in a normal system. Other example, I'm going to show you what I think is a really nice tool when working with Docker. It's called Nixery. How does that work? Well, let's say that I want to, I need a container, and in that container, I would like to have a shell. I would like to have Terraform, maybe the FFmpeg video editing program, and what else? That's a good start. Well, I can do docker run-ti nixery.dev/shell/terraform/ffmpeg. And if you want other packages, you just add them after that, slash this other package, etc., etc. When you do that, this is going to connect to nixery.dev, and what it does is ask nixery.dev, hey, can you send me that image? And what nixery.dev does is, on the fly, it's going to assemble an image with these packages. I wonder if we might be facing no, there we go. I was like, oh, this is the demo effect. It doesn't work, but no. Yeah. So on the fly, it did assemble an image with these packages. And you can see that this image has a lot of layers. You know, it's so small, we can't see them anymore. So how does that work? This is using a system called Nix, N-I-X, and Nix is it's a whole ecosystem where you have Nix, which is a package manager and functional language. You have NixPKG, which is a collection of packages. NixOS, which is a Linux distribution using that system and collection of packages, and Nixory, which is specifically for Docker images, something that leverages all that to generate images on the fly. Nix is one of these, I don't know if I should say tools or ecosystems or whatever, but you know, it's I'm not gonna lie, it's pretty complicated. But once you go past that bump of complexity, the folks using it are like, wow, this is awesome, this is so great, it's like magic. And so you have lots of advantages using that. My goal here is not to sell you on the idea of Nix or NixOS or NixPKG or whatever, but just that little example, Nixory. And what Nixory does, it's a little bit, you know, functionally, it's a little bit as if when you have something like that, it's a little bit as if it were building a Dockerfile, you know, on the fly. Imagine something like this: run install Terraform, run install FFmpeg. So it's a little bit like this. Imagine like when I try to pull the image doesn't exist yet, but Nixory is like, hold on, I'm going to build the image real quick and send you the image. Now, it doesn't really write a Docker file and it doesn't really build an image. It's using another mechanism, and I'm not going to dive into these details, but that's why you end up with an image that has so many layers. Because these layers correspond to all the dependencies of these packages. And there we go. Now I'm in a container where I have a shell and I have some basic tools. I also have Terraform and I have FFmpeg. And again, if I want more programs, I just add them to the list. When is this useful? Couple of examples. Maybe sometimes you want a container with a couple of tools and you're like, there we go, I don't need to install packages. Another very useful example is when you are building a CI/CD pipeline or a deployment pipeline, and there is an increasing number of pipelines that are using container images, whether you are on GitHub Actions or GitLab or CircleCI, etc., etc. Very often you can give an image and you're like, well, I would like an image with, I don't know, Terraform and Helm and OpenSSL to manipulate my keys and certificates and etc., etc. Option one, I could create these images myself. No, sorry, let me backtrack. Option one, I'm very lucky and there is actually an image exactly like that exists and that I can use. Awesome. Now, yes, if you just need one tool, generally there is an image with the tool in it and it's great. But if you need a combination of tools, which is very often the case in CI/CD pipelines, then it's pretty rare to find exactly the image with the combination that you want. So option one, yeah, I could build my custom image. Or option two, I could use something like that and automatically get the combination I need. All right, so in that case, we end up with images with tons of layers. And in fact, if we look into the code of Nixory, there is some pretty clever stuff in there to reduce the number of layers, because otherwise there would be too many layers. All right. Now, us, when normal humans writing normal Docker files, not weird magic Nick stuff, do we really need to reduce the number of layers? Not necessarily. What I do is that I try to not have too many layers in that just don't serve any purpose. So that's what you can see here. Like that's the kind of optimization I would do. Install all the packages in a single layer. But I wouldn't go out of my way to excessively reduce the number of layers. Example, let's say that I have a Docker file with something like this. Run this, run that, run whatever, and run that other thing. So imagine I have a bunch of run commands like this. If I want, I can optimize that by doing run this and that and whatever and that other thing. Okay, so when would I pick one or the other? Typically, if these things could kind of change independently from each other, like if this is installing and compiling a really big thing, and now this is a smaller action, then maybe I want to separate them. Maybe I want to split them. And I'm going to go back to my video game metaphor one more time here. Imagine you're playing a super difficult video game and you have a very long level. It's very long, but it's also pretty easy. And then at the end of that level, you have the end level boss, which is very, very hard. Well, if you can save game, it's a good idea to save at the end of the long and boring sequence just before the fight against the end level boss, right? So that you don't have to replay the whole thing every single time. Exactly the same thing with my Docker files. If I have a bunch of very long things and then an action that I need to redo many, many times, I probably want to put them in separate layers so that I can replay or rebuild them separately. So that's one way to kind of combine my layers. Now, what I would probably do, in that case would be more like this. Run this and that and whatever and that other thing. What did I do here? I used the backslash at the end of the line. This is a very common thing, not just in Docker files, like in many other things. When you have a command that should be multiple lines, but you don't want to have when you have a really long command and you don't want to have one giant long line, but you want to separate things, you can put a backslash at the end of the line and continue on the next line. So that's what we would do here. And personally, what I like to do in that case is put the end like this so that it's nicely aligned like that, and kind of visually I can see, oh, this is one big coherent block. Now, if you've done a little bit of shell scripting, you might be wondering, hey, why didn't he do like this with semicolons? Like that might have been our first intuition. If I have multiple commands to execute, I do this, semicolon that, semicolon whatever, etc. Well, I strongly do not recommend to do that, and I would strongly recommend that you do that instead. Why? What's the difference? When you put semicolon, it's going to execute all these commands no matter what. So for instance, if here, let's say you have an error here, you have a command that fails, if you use that version, it's going to, kind of power through all the commands one after the other, even if there is an error. Now, if you do that one, when you put the double ampersand, it's going to continue to the next command only in the previous one succeeds. So if you do something like this, it's going to execute this. And then if it works, it's going to move to the next one. And if that one doesn't work, it's going to stop right away and report an error. So I think it's better in the build process to stop immediately if there is a problem rather than continuing, and then you end up probably with a broken image because one step failed early in the process. All right. So that's a pretty easy way to reduce the number of layers. What else? We talked about that one a couple of times already. Remember with Java and Maven, we saw how we could avoid reinstalling dependencies every single time. And we're going to see a third example of that. This is an example with Python code. And so here, this is I would say, bad Docker file. I mean, it's not bad, but it's just that each time you change a line of code, even if you change, like an HTML template or a CSS or JavaScript, each time you change a little something, it's going to reinstall the dependencies. It's going to re-execute that pip install command. And if that pip install command installs a lot of dependencies, then this is going to take a lot of time. So this is a better Docker file. If you can look at the difference, what we do is that instead of directly installing the requirements, I mean, we copy the requirements files. See the difference? Instead of copying everything, copy just the requirements file, and then we copy everything else. So that way, if I change a JavaScript or CSS or HTML file, I am not reinstalling all the dependencies. I think this is probably the number one tip to improve Docker files, because this is going to reduce build times a lot. Now, something a little bit more subtle. Let's say that I want to bring in a file in a container image. Let's see a little example. Let's say that I have some big file. Okay, let's say big file, and I want 100 megabyte file. Okay. Okay, so my custom image, move that here. All right. Oops, sorry, my custom image. My custom image, there we are. So I have this file here, 100 megabytes. Let's pretend that this is some machine learning model and I need to put that in my image. Okay, as a little aside, it's not always a good idea to put machine learning models, model weights in the image. There is a big it depends here. But let's say that in that case, I weighted the pros and cons and I decided I wanted to put my machine learning model in the image. So I'm going to do something like this, where from Ubuntu, and maybe I do copy the file, well, copy ... and then I'm going to do workdir/data, and then move /model.pck in the current directory, something like this. Okay, so if I look at this Docker file and I'm trying to think about what will be the size of the image, thinking, well, I'm using Ubuntu. What's the size of Ubuntu? Ubuntu is 77 megabytes. My model.pck is 100 megabytes. So let's do the math. 101 plus 77. My final image should be like 178, 79 megabytes. Well, let's try. So let's say docker build dot -t machine learning. And now I do Docker images machine learning. And I'm like, wow, it's 288 megabytes. What's going on? What's going on is that, again, because of historical reasons, when you move a file in a build process like this, you know, in a perfect world, if we think about the layers, we would think, that layer here, it's going to contain some information telling that the file was moved from one place to another. Well, no. Layers technically are extremely simple. So a layer cannot say that a file was moved. The only thing that a layer can do is this file was removed and that file was created. Okay, so what that means is that this is copying the model, so this is going to be 100 megabytes. This is just creating a directory, so this is going to be almost 0. And now this is moving the model, and so it's again 100 megabytes. And if we don't believe it, we can do Docker history machine learning, and we can see that, yep, indeed, unfortunately, that thing here, you know, we could expect that since we're just moving a file, that the size should be really small because there isn't really any new data. There is no new information in there. Well, unfortunately, there is, because, again, we can't move the file. We can only remove and add it somewhere else. So we have to re-add that file in the layer. So that's why we end up with a very big image here. It's kind of a technical limitation of Docker files, but once you are aware of it, it's very easy to avoid doing that. You know, it's like, well, just put the model in the right place and that will be fine. Now, what's a little bit annoying is that if you change permissions, you know, like run chmod 600 model.pck, and we build, whoops, sorry, my comment here, I should not have left these comments right there. Okay, Docker build. And guess what? Now it's 300 megabytes. So that means that even something so simple as changing permissions, it means that the whole file needs to be included again. Now you might think, wow, that was really a very bad design decisions, and the folks who made like the first versions of Docker Builder maybe were not very smart. So I can give you a little bit of explanations around that. Before Docker, we had another container engine, which was powering the .cloud platform. It was a software as a service system comparable to Heroku. And we had, in fact, an extremely smart layer system using Mercurial and extensions. There was an extension called MetaShelf, so that, yes, indeed, when you move a file or change permissions, etc., it would do the right thing and be very optimized, etc. Very efficient, very disk space efficient, but not very fast. In fact, the build process was so slow and so cumbersome that we had like one engineer on the team who knew how to build and rebuild the images, and it was a huge pain, and nobody was doing it the rest of the time. So when we switched to Docker, we decided to learn from that and like, okay, instead of trying to do something super smart to optimize layers and whatever, no, get rid of that and do a system that is very simple and very fast. And that's what we really need. We want the build process to be fast. And yes, sometimes there's going to be some inefficiency like this, but it's not a big deal. All you have to do is put the file on the right place with the right permissions the first time, and that's it. So that's what I'm explaining here. If you have something like this where you copy a file and then change ownership and then change permissions and then move it, no, don't do that. Instead, put it on the right location in a single command on the first try. Very similar example, when you have an archive, a tarball with a bunch of files in it, we could think, oh, I'm going to run, download the archive, run, uncompress the archive, run, get just the files I need and put them on the right place, run, remove the archive. Well, no, if we do that, we end up with the archive will not be visible in the final image, but it will be in the layers. And so we will have a very big image. Like it's going to be really weird, because you could have an image that looks small, because if you look in the container, you're like, well, there is almost nothing. But in fact, you have lots of layers there, and the layers need to be downloaded as well. If you are using Git, you might have experienced something similar. If you, let's say you have a Git repo with a little bit of code, very simple code, maybe you have like 3-4 files, a few hundred lines each, so very small repo, and accidentally you add a huge image in that repo. You just took a selfie, it's 10 megabytes, and you add that to your repo accidentally, you commit and you push, and then you're like, oops, that was a mistake. So you git rm the image, commit, push, like I remove the image from the repo. But now, each time you clone that repo, you're still going to download that image because it is in the Git history. So that's the same thing here. Once you've put something in a layer, it's going to stay in that layer. And when you pull the image, you're going to pull these layers and you're going to pull these files, even if they have been removed later in the final image. So in that particular scenario, when you have an archive and you want to extract some files from the archive, you can do that in a single command like this with the technique I was showing you earlier. So we use ampersand to chain multiple commands and / to have them on different lines so that it remains more readable. All right. So that's a first. We could go on and on and on with many tips, tricks, etc. But these are honestly the most important ones. When I review Docker files and try to optimize things, like these ones are frequently occurring issues. So I don't want to flood and overwhelm you with 1 million techniques and etc. I'm just like, okay, these are the main ones that it's useful to keep on your mind when writing Docker files. Now let's see some examples. Let's say that we go out there and look at Docker files and try to understand why they did things that way. This is an extract from the WordPress official image. And in that image, you can see some interesting patterns. So first example, you can see a bunch of commands here, apt-get update, apt-get install, remove a bunch of files, do this, do that, in one single layer. Another example, same image, you can see they download the tarball, then they verify the checksum, untar, remove the tarball, set permissions. Once again, do all these things in a single layer to optimize disk usage. That command here, you will often see that in Debian and Ubuntu images, rm-rf var lib apt list. What is that? Remember on the first day, we've built the Figlet image. Docker history. Figlet, which one? Docker file. When we built the Figlet image, we did from Ubuntu, so that's the 2 layers that you have here, apt-get update, apt-get install Figlet. You're like, when you do apt-get update, it downloads almost 40 megabytes of, well, I don't want to say useless files, but we only need these files to do the apt-get install Figlet. Then we don't need them anymore. So it would be nice if we could remove that from the final image. That's exactly the point of having that rm-rf var lib apt lists here. It's to remove these files that we don't need anymore. One time somebody asked me, hey, can't we just like yank out that layer? Can we remove a layer from an image? Well, yes, you can. You can do some, I would say, layer surgery. I don't particularly recommend it, but just in case, layer remove, just in case if someone wants to, I would say, almost play Mad Doctor with images and layers, there is that project here that can do that. It's really a hack, so I don't recommend that you would use that in your CI/CD pipeline, etc. But if some scenario, if for any reason you're like, oh, I really need to remove that layer from an image, yes, it's possible. Now, sometimes you can also see Docker files like this. And it looks like on this Docker file, they did the complete opposite of what I was telling you before. Every package is installed separately, with apt-get install, apt-get install. It's interesting, like very different. And yet, this is a good Docker file. Why? Well, I wrote this Docker file. Okay, to clarify, it's not a good Docker file because I wrote it. It's a good Docker file because the goal is different. This is the Docker file of the WordPress image, which has been downloaded like millions of times, if not tens or hundreds of millions of times. So it's interesting for that image to try to optimize as much as you can, because if you can save even like 1 megabyte, 1 megabyte times 1 million downloads, that's 1 terabyte of bandwidth, 1 terabyte of network traffic that you can save. And if the smaller image means that it's maybe like 10 seconds faster to download for most people, then it means that you saved like thousands of people, tens of thousands, sometimes hundreds of thousands of people, you save them 10 seconds each time. So that's a lot of time saving overall. So that's great to do that. It's a little bit more work for the person writing that Docker file, but if they're saving so much time for everyone else, that's great. Now, this image, that image has never been pushed or pulled ever. This is the image that I use to preview my blog. My blog is on GitHub Pages, and it's using a blog engine, like a static web page generator called Jekyll. Jekyll is in Ruby, and I don't know Ruby very well, so I didn't want to install that locally on my machine. Instead, I wanted to have that in a container. So I have wrote that Docker file so that I could have GitHub Pages and that whole environment running locally. But I don't use that image in production anywhere. I never push that image. All I want is a Docker file that is really easy to read, really easy to maintain, so that whenever I need to rebuild that or update that, it's really easy for me. So it's very important to keep in mind that when you have different use cases, different scenarios, you will go to very different solutions. There is not a best method. There is not like an absolute best way to do things. It depends on the use case that we're optimizing for. Other examples, I like that one because the name seems very fancy, you know, multi-dimensional versioning systems. This is because on images, you only have one tag, but sometimes you can have multiple versions in the image. So this is an example coming from the official Plone image. And Plone is a content management system. It's fairly complex. It's based on Zope, which is itself like an object database system, which is itself built on top of Python. And Plone is fairly complex to set up, so often you use a special tool to set up Plone that you have multiple options, but one of these options is this thing called build out. So basically what I'm getting at is that when you install something like Plone, it's not just, oh, I have Plone 1.5.0. It's like, well, I have Plone 1.5.0 and I have this version of Python and that version of pip and that version of build out and that version of this and that and whatever. And I want to capture all this information so that if I'm looking at the image, I can easily see, okay, what's in there basically. I can give you another example maybe. So I have an image called Shpod, that's for shell in a pod. And this is my own personal Swiss Army knife of containers. So it's a container image that has something like 20 or 30 tools that I use very often when working with containers. And if I do a Docker inspect on that image, you will see that we have, my bad, sorry, okay, that was a bad example actually, but okay, it's a good counter example. Okay, in that image, let's run it. So in that image, I have really like a ton of tools. I have the Docker CLI, I have kubectl, I have Helm, I have HTTPing, I have JQ, I have lots and lots of things. It would be nice if I could see the versions of these tools. So what I did in that particular case is that I have a versions.txt file, and in that versions of txt file, I tried to list all the versions of all the tools so that you can have a good overview. But it would be even better if I could see that with Docker inspect. If I had somewhere something that would tell me in that particular image, this is the versions of all the tools. So that you know, here in the environment. I don't have that at the moment, but maybe I might change it in the future. So that once again, when you do this Docker inspect, you can see immediately what versions you have right there. What else? It's very often when you have an image, you run a program, right? Like that's what we saw with CMD. And very often you also use a wrapper. So I can give you a little example. Let's see, it's again in my custom streaming platform. So it's this is a, I don't know how common is that pattern, but here what I want to do is add a few lines of custom configuration to my Nginx web server. And so the way we do that in that case is that I have a bunch of environment variables here, Nginx rtmp conf. And so if I Nginx rtmp into my .env file, you can see like all these things. So basically, these are the configuration lines that are going to allow me, so this is my IP address, so this is going to allow me to push my video stream, and then it's going to relay the video stream to the African and European mirrors. So that's what we have here. So when you have something like that, like you have some options that you want to give to your container. One option would be to write a custom configuration file. So yeah, I could put these lines into a little Nginx configuration file, and then I would copy that to the container one way or in another. But it would require me, it would require some extra steps. Like I would need to maybe build a custom image with that configuration, or I would need to generate the configuration and then pass it to the container. What I decided instead is I want to configure everything through the environment. This comes from a set of principles called the 12-factor app. Maybe you've heard about that before. 12-factor app. So it's when is that from? I think it's almost 10 years old now. But it's a bunch of principles and generally pretty good ideas about how to architect and also configure applications. And one of these items is configure through the environment, basically. And so it explains like why you want to do that. So I wanted to follow that principle on my streaming stack, configure that only with the environment. The problem is that Nginx doesn't work with environment variables, at least not for that. So I had to somehow take these environment variables and transform them into a configuration file. So that's what I do in that compose file here. Where is it? So that's basically get all the environment variables that start with nginx rtnp-conf and put them in a configuration file. So in that case, I am doing that with a command, but this could be integrated into your image. What I'm getting at is that imagine that you are running any kind of server. It could be Nginx, it could be Tomcat, it could be whatever you want. And that thing requires a configuration file. But like me, you decide, no, I want to use this 12-factor app principles because it seems like a good idea, and I only want to pass environment variables. I don't want to give you a configuration file, only environment variables. One way to reconcile the two is to use a little wrapper like this, where you get the variables, turn that into a configuration file, and you do that at runtime when the container starts. So it's going to be very common to have a CMD in your container that will do something like that. In that case, unfortunately, there was no CMD doing that for me, so that's why I'm doing that here. But if this were my own custom image, then I would very certainly integrate that into the CMD instead. If you're a little bit confused by this whole thing, think about what the Postgres image is doing. Remember when we built for Wordsmith, when we built the DB image, we put the words.sql in the special entry point directory. Where was it? Wordsmith DB Docker file. Remember, we just copy that SQL file in the right directory, and then there is a little bit of magic to automatically load that in the database. And the little bit of magic, that's what we call the entry point or the wrapper of the container. So that means the container doesn't immediately start Postgres. Instead, it goes through a number of steps and then starts Postgres. So very common pattern. Can we replace that command with a .sh file? Absolutely. And the only reason why I did not do that is because I did not want to use a custom image. If we go look here, you can see that I'm using image Tyangolo/Nginx RTMP, and I'm very embarrassed because I don't remember the name of that person, but he's the author of FastAPI, Federico Ramirez, I think. So basically, that guy made this really nice image, and I was like, well, I'm just going to use this image. You know, if somebody already made an image for this, that's less work for me. So let's do this. So, you know, like I kind of have two options. Option one, I write my own image. I mean, I build my own image. So I would write a Docker file where I would compile Nginx with the RTMP module and configure everything. And then, yes, in that case, I would probably have put my, my command here into a shell script. Option two, I noticed, this guy made this really nice image and I want to save myself some work, so I'm going to use his image. But then, since there is no shell script to do that in his image, I'm going to put my own custom command. Trade-offs. I'm not saying that one way is better than the other. You know, I just went for that option because for me it made more sense, but you can do whatever works best for you. All right. Another example of things that we might want to do. I mean, another like good idea, good recommendation is factoring things. I think we already talked before about the DRY principle, DRY, don't repeat yourself. This is another example where, so this is in the Node.js official image, and you have the Node version showing up multiple times. So when you download the tarball, it's 2 times in the path, in the URL to the tar file. And then you download the checksum, the signature. Again, you have the Node version. So if you look at that Docker file, we have the Node version like 1, 2, 3, 4, 5, 6 times. Option 1, I could just hard code 10.2.1 each time. And now when I need to upgrade my image, I would need to search and replace each time that the Node version appears. Or option 2, I just put that in a variable and I use the variable. Strongly recommend that you use the variable because it makes the maintenance of your Docker files much easier. And side benefit, now if you inspect the image, you will see the Node version in an unbound variable, so it kind of gives you extra information about the image. All right. Another thing, sometimes we have conflicting information, you know, like because one principle when you work with containers, we often say, oh, we want to use the same image in dev and prod so that when you have a bug in prod, it's really easy to reproduce the problem in dev. So we want the same image everywhere. But then conflicting information, we say, well, in production, I don't want to enable debugging and etc. But in dev, however, in dev, I want debugging, I want auto reload, I want like a bunch of things like that. So how do we reconcile these two apparently conflicting imperatives? Well, one way to do that, I'm going to give you a concrete example with the Training Wheels app. If I look at the Training Wheels app, so it's a small Python app, and what we did here is that in the Docker file, we put the production stuff. So in production, we use Gunicorn. It's a web application server for Python WSGI apps. So we use Gunicorn, and we say we want 10 workers. And that's where we would put stuff like, yeah, and use the threading model and this and that, and maybe like TLS or whatever. So now when we run in dev, we're going to use a compose file. And in that compose file, you're going to see something a little bit different. You can see that we override the command. We say just use python counter.py. Instead of gunicorn dash dash this dash dash that, we're like, no. In dev, instead of using gunicorn, which is more like a production server, in dev, we're just going to run the WSGI dev server. And we're also going to enable more verbose debugging by setting that environment variable. So the advantage of this method is that it's the same image. So when there is a problem, a bug or whatever, at least you know that you can get the same image. It's not, oh, the same image, but there is one different file. No, it's exactly the same image. And we change the behavior by changing the command or changing the environment. So that means that if I have a bug in prod, well, I could start by trying to reproduce it in dev with my different server and debugging mode, etc. But if I can't reproduce the bug, then I could try, well, okay, let's comment out that command, let's comment out that variable so that we get exactly the same configuration as in production. So that's a pretty good way of doing things. Instead of building multiple slightly different images, let's try to have a single image and configure that image, basically. All right. The key thing, with all the tips and tricks I listed in this section, and I'm going to repeat what I told you the other day, which is that the main point of Docker and containers is to make our lives as developers easier. So if at some point you try to apply one of these techniques, but you're like, no, I'm sorry, but that doesn't work, and my builds are super slow, and etc. That's fine. Just leave that technique aside. You don't have to use all these techniques. These techniques, they're not solutions looking for a problem. They're more like a collection of tools that you can use if you hit a specific problem, if you are in a specific scenario. Going to give you another example. A few years ago, I was teaching a Docker class, and the folks in the class were telling me, hey, we have that really weird and interesting problem. Unit tests. If we run the unit test locally, it takes, 30 seconds. When we run them in containers, it takes 30 minutes. What's going on here? And as a result, of course, as you can imagine, nobody was running the tests anymore because it took 30 minutes. Nobody wants to wait 30 minutes after making some small changes to the code. So in that case, the first solution is, well, just run the tests locally. Don't force yourself to run the test in containers where it takes half an hour. Just run the test locally. Now, the best solution is, of course, to try and understand what's going on. And it turns out that in that case, this was in the early days of Docker Desktop, etc. And they were using a system to synchronize files between your developer machine and your container. And that system was conflicting with the sharing file mechanism of Docker Desktop. So long story short, each time that you change the file on the machine, that system would replicate the change in the container, but then the change would be replicated back on the machine and then back and forth and so on. So we basically had two replication systems that were, I can't even say fighting with each other, but kind of playing an infinite game of ping pong between each other, just like copying files over and over back and forth. And of course, that was slowing down everything. So in that case, sure, there is a nice and clean solution, which is to fix that replication system. But in the short term, just run the test locally. If working in containers makes your life miserable, don't work in containers. Just work locally until you find the solution to the problem, and that's fine.